Yo, what's up, guys? We're drawing close to the end of the semester. We have your probability test. This is your review. Your test is tomorrow. Let's jump right in and good luck. Alright, so on this first example right here. So, right here, number one, upon arriving at an intersection of College Avenue and Main Street, the light is green 35% of the time. You drive through the intersection every day, Monday through Friday, on your way to work. What is the probability that the light isn't green when you get to the intersection tomorrow morning? So, isn't green. Oh, sorry about that. Isn't green is basically not green. When is it not green? So that one's kind of simple, right? You have 1 minus 0.35 equals 0.65. Oops, 0.65. Which is 65%. Alright. Now for this one, it says, suppose you find out that the probability of the light, that the probability that the light is yellow is 0.04. Alright, so that reading is 4%, guys. What's the probability that the light is green or yellow? Or, alright, remember when it's or, we add. Alright, so we have 0.35 plus 0.04 equals 0.39. Alright, or 39%. Alright. Alright, what is the probability that the light is red? Alright, the light is red. Well, let's look at it. The light is green or yellow 39% of the time. So if I figure out what's remaining, that would be red, right? So if I do 1 minus 0.39, that's going to be 0.61. So that means it's red 61% of the time. 0.61 or 61%. Alright. Now D, it says, what's the probability you find that the light is red both Monday and Tuesday? So and, alright, and means multiply. Alright, so Monday would be 0.61, and then Tuesday would be 0.61, and tells me to multiply, so if I multiply those, that gives me 0.3721. Alright, and then for E, it says, what's the probability you don't encounter a red light until Wednesday? Well, we gotta look at Monday. Monday. So Monday, remember, we don't encounter a red. Alright, so that means red or green. Yellow or green, which we found up it was 0.39. Alright, and then Tuesday, still, it's not red, so 0.39. Alright, and then Wednesday, we finally get our red light. So we can multiply these and we get 0.0928. Now, number 2, a coin is tossed and a die is rolled. What is the probability of getting tails and an odd number? So you toss a coin, the probability of getting the tails is 1/2. And you roll a die and you want to get an odd number. Well, there's 3 odds out of 6 total. Which again, that's basically 1/2 times 1/2. Or you can do 3 out of 12, which is 1/4. Or you can reduce that and say 1/2 times 1/2 is still 1/4. Alright, right here it says 2 dice are rolled, 1 blue and 1 red. Alright, what's the probability of getting a 3 on the blue die and a number greater than 4 on the red die? Alright, so right here, to get a 3 on the blue die, alright, 3 on the blue die is 1 out of 6. 1 out of 6. All right, and then when you think about getting a red dot, a number greater than 4, that means you can get a 4 or a 5, right? So you want the probability of 4, all right, or 5, all right, or 6 actually. 4, I'm sorry, 5 or 6 because it says greater than 4, so 5 or 6. All right, right there. So that's 2 things. So that's 2 values out of 6, right? So we just multiply those right there. That's going to give us 2 out of 36, which is 1/18. All right, right here, suppose that 23% of adults smoke cigarettes. So we have adults, man, 23 smoke. All right, that means, and remember, each one of these branches right here must equal 100. So this is 23, then this is 77 right here. All right, 0.77 are non-smokers. Now it says if it's known that 57% of smokers, 13% of non-smokers develop lung conditions by the age of 60. So of the smokers, 57% has lung condition. All right, and of the non-smokers, 13% have lung cancer. So that means, or lung condition, excuse me. So right here, of this 57, because remember, each one of these are supposed to be 100%. So out of this 57, if this is 57, this is 43. All right, which is no condition. And then if this is 13, then this is going to be 87% has no condition. All right, so it says, what's the probability that a random selected adult smoker develops a lung condition? All right, so again, a randomly selected adult smoker, so we're looking at this side right here, an adult smoker develops a lung condition, so lung condition. All right, so we have 0.23 times 0.57. All right, man, I don't even know why that's yellow. Anyway, when you multiply that, that's going to give us 0.1311. All right. All right, number 5. All right, let's see. Tim won a contest on a radio station. The prize was a restaurant gift card and tickets to a concert. He can select one of 3 different restaurants and tickets to see Taylor Swift, Kelly Clarkson, Beyonce, or Pharrell. How many different ways can he select a restaurant followed by a concert? So, restaurant. There's 3 restaurants, right? And then tickets to see 4 different artists, right? So that is 12 different combinations, all right? All right. A college student is preparing a course schedule for next week. The student must select one of 2 mathematics courses. All right, so I'm gonna select 2 math courses. All right, one of 3 science courses, and 5 courses of social studies. All right. What do we have right here? So 2 times 3 is 6. 6 times 5 is 30. So 30. We got 30. How many ways can 10 horses in the Kentucky Derby finish first, second, and third? Now we reach a permutation equation because order matters. All right, because if a horse is first versus second, that's totally different, right? It's different money. All right, so first of all, we got 10 horses. All right, we got 10 horses, and we want to see how they finish. Where N is 10 and R is 3, right? So it's always NPR. So 10, all right, right there. We punch that in our calculator. And if you're unfamiliar on how to get to that, let me show you. All right, so here in my calculator, we got 10, math, right here, 2, NPR was 3, 720 right there, okay? 720. Alright. Number 8, right here it says, for a certain experiment, 3 students are randomly selected from a class of 15. How many groups of 3 students are possible? So right here, I'm just choosing 3 students for a group. The order doesn't matter. It's not first place, first, second, third. It's not president, vice president, treasurer. It's none of that. It's just, I need a group of 3. So N is 15, R is 3. All right, so this is going to be 15. All right, choose 3. All right, and we do that the same way. All right, back to the calculator. 15, math. Right at 3. All right, 455, 455, 455 combinations. All right. All right, for number 9 it says the stats. The State Narcotics Bureau must form a 5-member investigation team. All right, if it has 25 agents from which to choose, how many possible teams can be formed? So again, man, this one just says we're forming teams. It doesn't say I'm looking for a captain, a sergeant, a lieutenant. It's just saying I just need groups of 5. So that's 25 is N, right? And R equals 5, all right? So that's 25, choose 5, all right? And you do that in your calculator, 53,130, right? All right, there are 5 finalists in the Mr. Rockhill pageant. In how many ways can the judge choose a winner and a first runner-up? So, okay. This one order is gonna matter. All right, there's 5 finalists. All right, and we gotta choose 2. All right, we need to choose first runner-up and the winner. All right, so that's 2. So here the order matters, right? So that's gonna be N with permutation 2, right? So NP 2. Oh, not N. I'm sorry. 5. 5. There we go. All right, and we do that. That's going to give us 20 right there, okay? Now, number 11. Number 11 says the security code for... All right, the security code for your garage door is 5-digit number. All right, you know the first 2 digits are 12 because you were born in December. So the first 2 digits are 12, right? But you remember that the last 3 numbers, but you can't remember the last 3 numbers, excuse me. You recall that the last 3 digits are all odd numbers, but you don't know the order. All right, what is the maximum number of codes you would need to try in order to find the correct code? All right, so that's a number. It's odd. That's a number. It's an odd number, and this is an odd number as well. All right, these are all odd numbers. Now, let's think about it. How many odd single-digit numbers are there? Well, you got 1, 3, 5, 7, 9. So that's 5, 5, and 5, right? So that's 5 times 5 is 25 times 5 is 125. All right. The reason I didn't really like this, you only have one option right here. It's 1. We know this is 12, so that's 1. We know this is 1 as well. So 1 times 1 is 1. 1 times 125 is 125. All right. That's really it, man, to it. All right, you just got to make sure you know how many odd numbers there are or how many even numbers if you had to do it. But when it says 12, like this is 1, this is 2, that's it. This can only be 1, so it's 1 possible option. This can only be 2, that's 1 possible option. But this one here, this number here, could be 5 different numbers. This could be 5 different numbers or 5 different options. This could be 5 different options, okay? All right, Number 12 here. Number 12 says, your state license plates, your state issued license plates consisting of numbers and letters. All right. How many possible license plates can be issued with the following conditions? So right here, all right, 2 letters followed by 3 numbers, and the numbers cannot repeat. All right, so cool. So for this one, 2 letters. So this is going to be a letter. There's 26 letters. All right, 26 letters. So this could be letter, 26 options, 26 options. Now the next 3 have to be numbers. But think about it, right? There's only 10 single-digit numbers. So 0, 1, 2, 3, ... 9, right? All right, that's 10 numbers. Count them out, all right, if you need to. 0 through 9 is 10 numbers. So there's 10 possible options for this number. All right, but there's only 9 for this one. And the reason being is because whatever number you put here, you cannot repeat it. All right, and so on for this one. There's only 8 options because you cannot repeat whatever one is here. All right, so when you multiply that, 26 times 26 times 10, 9, 8, it's going to be 486,720 possible combinations. All right. Now, B says 4 letters followed by 2 numbers. No restriction on letters or numbers. So that one has no restriction whatsoever. So letter, number, not hashtag. All right. So 26. And again, it doesn't matter. You can repeat. All right. There's no restriction. All right. So that's 10. That's 10. So that's 26 to the 4th times 10 squared, or 26 times 26 times 26 times 26 times 10 times 10. And that's going to give you a whopper 45,697,600. There you go, right there. All right. Now, 3 letters. Letter. Only vowels only. So A, E, I, O, U. All right, that's 5 values. I know you're like, sometimes why? No, A, E, I, O, U. So 5 options. All right, and then followed by 2 numbers. Must be a 1 or a 0. So 2 numbers. All right, so number, but it must be a 1 or a 0. So that's only 2 options for numbers. All right, so it's 5 times 5 times 5 times 2 times 2. That's going to be 500. All right, 500. Okay, guys, by the way, you're multiplying these numbers if you haven't caught that by now. All right, you multiply all these numbers. All right. How many successful ways can a letter in each word be written? All right, so remember, what you need to first do is count how many numbers. There's 1, 2, 3, 4, 5, 6, 7. There's 7 numbers, so that's 7 factorial. All right, now how many letters repeat? 1, 2, 3. So there's 3 S's. All right, and then there's 2 C's. All right, so that's what this will look like, okay? Do that right there. So when you punch this in your calculator, you can literally, you just punch this in. This is all calculator work. Let the calculator work for you. So you have 7 math factorial divided by 3 math. See factorial right there, option 4. And then 2 math factorial. That's 420 combinations right there. All right, right here you have Archer. So 1, 2, 3, 4, 5, 6. 6 letters divided by what repeats, the R. So there we go right there. All right, when you do that, 360. And it's kind of, if you didn't want to do it in your calculator, you would just, never mind. It's calculator work, man. Make it easy for yourself. All right, Tennessee, 4, 8, 9. So we got 9. Now what repeats? The T doesn't repeat, the E repeats. So 1, 2, 3, 4. 4 E's. All right, the N repeats. 1, 2. All right, 2 N's. 2 S's. All right, so that's going to give us a whopping, drum roll please, 3,780. All right. Okay. For these next 3 problems, I took the liberty of writing these out for you because I want to make sure you really understand exactly the terminology at most, at least, more than, fewer than, exactly. Okay. These are the equations you should be using. Make sure you look at them clearly because I don't want you to mix up. This is a binomial PDF. This is. I just want to make sure you really understand what it is we're looking at here. Okay. So this first one right here says, what's the probability of tossing the coin 10 times with the coin successfully landing on tails exactly 3 times? So that's exactly 3 times. So that's going to be a binomial PDF. All right, so we have binomial PDF. All right, you let the calculator work for you. And we have 10 trials. The probability of flipping the coin, guys, is 1/2. All right, 1/2 or 0.5. All right, and then exactly 3 times. All right, so we'll punch that in our calculator, and that'll give us 0.1172. All right, now this one says at most 2 times. So at most, we're going to do binomial CDF. All right, so this one's going to be binomial of 10 flips. All right, 10 trials. Again, that probability is 1/2 and 2 times, because at most, the most you can have is 2 times. Okay? Now this one says more than 6 times. Well, more than would be right here, 1 minus. Let me do another color for that one. 1 minus. Oh, my fault. I didn't write down the answer for this one. The answer for this one is going to be 0.0547. Now for this one, at most, it says 1 minus. Binomial CDF of 10 times with a probability of 1/2. All right, and this is 6 times. So this one is 6 because more than 6 times, because right here, 6 is not included, right? 6 is not included. So right there, I won't do that. We get 30.37. Whoa, wrong. Sorry about that. Punch that in. 179. Okay. 7. So man, write these down. All right. So when you're taking your test, you have a reference. Right? This is important. Okay. Continuing, here's the same type stuff right here. It says, calculate the probability of randomly guessing 8 questions out of 10 multiple choice exams that has A, B, C, or D for each answer. So that's 4 possible answers. So you got to get 1 of the 4 to be correct, right? So randomly guessing 8 out of 10 correct. So this is exactly 8 out of 10. Exactly 8 out of 10. So this is going to be binomial PDF. All right, of the 10 questions, you got 1/4, or you can say 0.25. You can say 1/4 or 0.25. All right, and then we want to get exactly 8 right? So when you do this, you get an answer of 3.86 e to the -4th in the calculator. Well, remember, this tells me I need to move that decimal to the left. -4 is to the left 4 times. So I'm going to move this decimal. All right, let me do this as neat as I can because my handwriting's atrocious. 3.86. So I'm going to go 1, 2, 3, 4. There's my decimal. Fill these in with zeros, right? So this answer is actually 0.0001. 4. I'm going to round it like that. Because on the test, you're going to have to round 4 decimal places. So 0.0004. All right, would be the approximation right there. All right. See, that 8 rounds that up. All right. So, all right. Again, using the same strategies. It says you were taking a multiple choice quiz that consists of 8 questions. All right. Each question has 4 possible questions. 4 possible answers. Sorry. Only one which is correct. To complete the quiz, you randomly guess the answer to each question. Find the probability of guessing. All right, exactly 6. So there's that word exactly again. So again, if you have this, guys, you have a clear model. All right, so binomial PDF. All right, let's see. Excuse me. We have 8 questions. All right. There's 4 possibilities, so 0.25 again, or you can say 1/4. All right, exactly 6. All right, so it's going to be 0.0038. For this next one, it says at least 4 answers correctly. So at least. So at least tells us, and again, I got your model right here, at least. So 1 minus binomial CDF NP x minus 1. All right, so 8. Again, we're still at 1/4. All right, but instead of going, since it's at least 4, we're going to do x minus 1, which is 3. All right, and that gives us 0.1138. All right, again, see that right there? They said 4. All right, at least tells us minus 1 right here, x minus 1. Right, see? All right, less than 3 possible answers. Less than, so I have less than right here for you. Less than or fewer than, okay, right here. So what we're going to do right here is we're going to go, oops, I meant to cut that volume off. We're going to do binomial, oops, CDF of A trial, 1/4, or you can say 0.25, all right, 1/4, 0.25, and 2. Alright, and again, look at the model. Fewer than or less than. Alright, same thing. Alright, there you go right there. Fewer than or less than. Okay. X minus 1. And that'll give us 0.6785. Alright. Alright, 19. We're almost there. 19 says you roll a die. Alright. You will be paid $5 for an odd number, $2 for a 2 or 6. All right, if you get nothing, you get nothing if you roll a 4. Find expected value of money you get for one roll of the die. So hold up, a couple things. Let's address it. All right, so a couple things. The probability of rolling the odd is 3 out of 6, right, or 1/2. The probability of rolling the 4 is 1 out of 6. The probability of rolling the 6 is 1 out of 6. The probability of rolling the 2 is 1 out of 6. Right here, this says you get $2 for rolling 2 or 6. But the probability of 2 or 6, or means add. So 1 6 plus 1 6, right, equals 2 6 or 1/3. Okay. So here we go. Let's find this expected value. All right. It says you get $5. All right, for rolling the odd number. So that's times 1/2. All right. You get $2 for rolling a 2 or a 6. 2 or a 6 has a probability of 1/3. All right, and then you get nothing. All right, you get nothing if you roll a 4. The probability of 4 is 1/6. All right, so when we punch that in our calculator, all right, that gives us 3.17. So right here, the expected value is $3.17. All right. All right, right here it says a 911 service center recorded the number of calls received per hour. All right, the number of calls per hour for each week can be approximated by the following distribution. What is the expected value of number of calls received per hour? So this one, all right, you have it right here. All right, so times 0.01. We got 1 call times 0.1. Then we have 2 times 0.26. All right, then we got 3 times 0.33. All right, I'm gonna write these all out real quick. So I wrote it all out. All right, the probability of 0 is a 1% chance. No, 1% chance. Probability of 1 is a 10% chance. Probability of 2 is 0.26. Probability of 3 cars an hour, 33. So on and so forth. Probability of 70.03 or 3%. I punch that all in my calculator. And again, let your calculator guide you, man. You get basically 3.02 calls per hour. All right. Yo, that is going to conclude our video, man. Hey, really, I hope this helps you. I try to keep it as short as possible with being as detailed as possible. I hope this helps. Good luck on your test. Good luck on your project. Good luck on your final, and I will catch you later.